Hi, I'm Rob Bygrave and I'm giving you a quick introduction into Avaje metrics. What this is about is collecting application metrics for Java or JVM applications, and it's orientated for doing that in production. The application or how it works is that it uses an agent to instrument or enhance your existing application. So it could be a Spring application with Spring annotations like component and service and repository, or in our case with our example application it's a JAX-RS application. So what that means is that beans that are annotated with @singleton or @path, it will enhance the public methods and capture timing metrics on those methods. So let's get into that. So if we go to getting started page, basically to start with we need to add a dependency to our Maven project, and then also add in a plugin. So if we have a look at our example application, we've got our plugin here defined, and that's what this will do is we'll run the enhancement on the processes after they've been compiled by Maven. The thing to note here is this has got a debug level, so if you can set it to 0, that will be no extra output. 1 will give us a little bit of output, which we'll have a look at, and then 9 if you want to see a lot more detail on the specifics of the enhancement. And then if we go up here a little bit, we can see our Maven dependency here. So what does that mean with the enhancement? Well, basically if we look here, so I've previously run a Maven clean process classes. So what that does is that runs a compile, or goes through the compile, and then runs this post process classes after that, which does the enhancement. We can see all this output here with these add metrics parts, and those are actually adding the enhancement onto these various methods. So if we have a look at one here, so we've got a muse service, so that's the class, and here's a method here called resistance, and it's been enhanced to collect the timing metrics. So we can see those services, and our web API has also had those been enhanced. So here we've got a custom resource with a few methods on it. So if we have a look back here at our application, once we've done that, we need to add in some reporting into the application. So your existing application has been enhanced. Spring beans or JAX-RS beans have been enhanced with timing metrics. Now we need to get some of those metrics out of the application. So typically you add in a service that will we'll create a configuration here and say report the statistics, in our case every 10 seconds, but you might say 60 seconds. And then when we create this report manager, that will come along with a background thread that will run every 10 seconds, collect the statistics, and output them. So here we can see an example of what will happen here. So if we have a look at our application, for us we've got a metrics service. So this is a singleton. It's got a not timed on there, so you can specify if you want something to be not enhanced for metrics. And this is actually written in Kotlin, so this is a JAX-RS application, but it's written in Kotlin and not Java. So here we're creating our configuration object, and we're saying please report the aggregate statistics every 10 seconds. And then we've got something here for hooking up a Websocket listener, which we'll talk about, we'll show you a little bit later, and then creating our report manager. So that's all we need to do. This will use defaults, which will output the metrics, as you saw here, in a sort of a CSV format. So here we've got some JVM metrics, garbage collection, memory, threads, and here we've got our actual application classes. So we've got our application. Let's fire it up and run it. So this app will run using Jetty, and just a JAX-RS application, and it's up and running. Now before we do anything, what we'll see is we'll see output being created every 10 seconds. So let's have a quick look at our directory here, and we have our metric log already been created. So if we tail that, we see that every 10 seconds we get some output coming out. Now at the moment we're not doing anything in terms of hitting the endpoints, so we're just getting the JVM metrics, so they'll just pop out every 10 seconds. So let's do something. We've got a postman up here to hit our application, so let's hit it a little bit. So this is a fairly fast endpoint. Let's hit it a few times. It's taking about 8 milliseconds to execute. Now if we have a look at our output here, we can see that, I'll just stop that tail, we can see that along with our JVM we now have a metric here, a timing metric. So we're hitting customer resource, that's the method use data. We hit it 10 times. This is in microseconds, so 607 microseconds. Maximum time, sum, and the collection of this took 10 seconds. So if you set up your reporting to run every 60 seconds, that would say 60. If there were errors, so if a endpoint or a method through an exception, it would go into an error, a similar error count, error average, error max, etc. So we collect the statistics for errors and success into two separate, if you like, two separate lists of counts and averages, etc. So if we just keep that tail going for a second here, and we hit that again, let's hit it a few more times, and we can see we hit it 3 times there. And what we'll do now is we'll hit an endpoint that's a bit more interesting. So let's hit that guy. So this guy, this endpoint is going to call a bunch of methods in our service layer. So I'm just going to stop that tail. So we hit customer resource as been, and we only hit it once. It took 613 milliseconds basically, and it's subsequently called a number of things in our service layer, which we also have got timing metrics on. And so we can see that it's called these services in here. Now we can kind of know that we've called these services because that was the only thing, we were the only person hitting this endpoint. And this is good, except it has its limitations, that when you have your service layer being called by lots of different endpoints, it's hard to tell exactly where the time for a specific request went. So you can imagine if we were running a lot of concurrent activity, then it would be hard to tell where did this 613 milliseconds go to. So there's two different types of logs. So we're looking at this log here, which is going to run all the time, and it's going to, for us, output every 10 seconds, but you might set it up to be 60 seconds. And the performance collection of these metrics is relatively cheap. We're just aggregating values for counts and averages, etc. So it's very cheap. However, we also want to be able to diagnose where did that 613 milliseconds go. And in that case, we want to do something a little bit different, or a little bit differently. So if we have a look at our, we've got another set of endpoints here. So let's have a look at metrics all timing. What this does is it gives us the names of the metrics that all the timing metrics in the application. So we've got all of our services, all of our resources that have been with their methods and that have been enhanced. So we can actually filter that down. So we can say, okay, what's the metrics that have got that have customer as part of their name. So we can see 3 here, and then similarly you could filter that down. Now, if I can type. and we can see that there's only one metric here that maps to that that, if you like, wildcard filter. We've got another endpoint here, request timing, and this is showing us all of the metrics that we're actually currently doing request timing on, and actually that's none at the moment. So what we'll do is we will do something here where we will collect the next 3 requests for these 3 timing metrics. So when we hit the customer resource, has been or hello or use data, do a per request timing metric. Okay, so let's hit data and hit that. So that's pretty fast. Let's hit it a second time. Now what's happened there is that we've got a second log, and this log is different. So let's have a little look at that. What am I doing? So we've got our metric log, which we were looking at before. We've got a second log which is called metric request, and this is giving us a slightly different view on it. So it's basically saying we hit this guy and 100% of the time went to this guy, because he's not very interesting, he just calls himself. So let's hit a different endpoint which is a bit beefier. So we hit the customer bean endpoint, and that customer resource as bean, it's taken 111 milliseconds. So this is the first column here is depth, second column is the percentage of time that was taken, milliseconds, microseconds, and the actual metric. So that's most often the class and the method. Now we can look down here, and when we see zeros, the percentage zeros, it means these methods were very fast. So 52 microseconds, basically not material to the time that this is taken. So that's taken 8% here. So radio head kid A is taken 8% of the time. 91% of the time was taken in radio head the bends. And if we carry on down, we can kind of see that 81% of the time was taken by this Muse service. I do the real work around here. So the idea is that for the single request, we can get the percentage breakdown of where the time was taken in our enhanced metrics and all the metrics that we happened. So let's have a look here. So when we go request timing, let's hit this guy again. So this is showing us, we turned on request timing for these 3 endpoints, and we said please get 3 request timings. So here we've hit this endpoint once, and so we've only got 2 left. We haven't hit hello at all, so we've still got 3 there, and we've hit use data a couple of times, so we've only got 1 left there. So let's hit use data, and we can see that he came out here. Now if we have a look at the request timing again, now we're only collecting the 2. So what I'm saying here is that the request timing is basically more expensive. You will be more selective in what you turn it on for and how many times you get request timings. So you're not going to turn it on for the entire application for many millions of requests, or you might do that in development if you're keen on seeing the timing all the time, but you wouldn't do that in production. So in production you wouldn't go collect star 1 million. That's probably not a great idea. But what you do is you say, well, actually on the customer resource, for maybe a specific method or maybe all of them, I want to collect 1 metric. So please do that. So now the next time this guy's hit, this guy's hit, or this guy's hit, we will collect that timing 1 time. Now you can also make this part of your application. So if we have a quick look over here, you can set up a WebSocket. to listen to these events. So when we hit one of these guys, so let's hit bean again. So now our application, where we've got a WebSocket that's listening to that event as well, and we've just been told what the timing metrics was. So we've got the same as before, 612 milliseconds. It's not really a surprise there, and 81% of the time is going to do the real work. And if we hit another one, we get our message again here. So this is coming out here to this page that's got the WebSocket listening, but it's also coming out to our log. And that is the pretty much all the things I wanted to say about metrics. There's a bit more once you do refining names and such, but that's for a different video. And if you look in GitHub Avaje metrics, that's got various repositories here for the various parts of the project. Okay, I think that's pretty good. Cheers, bye.